For decades, we pictured the outer solar system as a graveyard, a collection of inert, crater-pocked rocks drifting in a perpetual deep freeze. Beneath miles of rock-hard ice, many of these moons harbor massive, active oceans of liquid water. This animated diagram compares the total volume of liquid water on Earth to the reserves trapped inside Jupiter's moon, Europa. Even though Europa is smaller than our own moon, its hidden ocean contains more than double the liquid water of all Earth's oceans combined. That water is sealed beneath an ice crust, estimated to be 10 to 15 miles thick. It is completely shielded from cameras and too deep to reach with current drilling technology. Because no human and no spacecraft has ever seen, touched, or sampled this water, scientists must rely on invisible physics to state with certainty that these oceans exist. The first definitive proof came from the Galileo spacecraft as it orbited Jupiter in the late 1990s. This diagram shows Jupiter's massive magnetic field. Jupiter spins rapidly, and as it does, its intense magnetic field sweeps across Europa. When a magnetic field sweeps across a conductive material, it generates an electrical current. That current then creates a secondary magnetic field. Europa pushes back against Jupiter with its own induced magnetic counterfield. The specific shape and strength of that counterfield dictates exactly what is inside the moon. To generate this particular magnetic signature, Europa requires a global layer of an electrically conductive fluid, a saltwater ocean. Researchers recently applied this exact mathematical signature to another of Jupiter's moons, Callisto. By filtering out the conflicting magnetic noise generated by Callisto's thin upper atmosphere, or ionosphere, they isolated the same induction signal. Scientists can measure the magnetic fingerprint from orbit, making direct photography unnecessary to confirm the ocean's presence. At Saturn, the Cassini spacecraft used a different method. Instead of tracking magnetism, it measured physical distortion caused by gravity. This wireframe overlay illustrates Titan's response to Saturn's gravitational pull. If Titan were frozen solid all the way through, its surface would only deform by about 3 feet. Instead, as it orbits, Titan stretches by more than 30 feet. That extreme physical deformation is only possible if the moon's outer crust is floating. It requires a flexible, liquid layer beneath the ice, allowing the surface to yield to Saturn's gravity. Then there is Mimas. It is a small, heavily cratered moon that looks completely inert. But Cassini detected a slight oscillation in its rotation, a gravitational anomaly known as libration. Over 13 years, Mimas's closest point of approach to Saturn shifted by roughly 6 miles. Models of an elongated, solid rocky core predicted a 12-mile shift. The only model that fits the observed 6-mile drift is a liquid ocean sloshing beneath the icy shell. A moon's physical trajectory in space, how its crust stretches and how its rotation wobbles, exposes the liquid state of its interior just as reliably as an optical camera. The evidence extends beyond orbital mechanics to the physical scars on the surface itself. Europa's crust is fractured into massive jigsaw puzzle cracks where the ice has physically separated and shifted. Even 3 billion miles from the Sun, the dwarf planet Pluto displays similar geological stress. The New Horizons mission photographed massive extensional faults, deep, sinuous canyons stretching hundreds of miles across Pluto's surface. This thermodynamic cross-section shows what happens when water freezes under the immense pressure of a planetary interior. The water condenses and shrinks into a compact, highly dense crystalline structure known as ice 2. If Pluto's subsurface ocean had completely frozen solid over the eons, the formation of ice 2 would occupy less volume than the liquid water. The entire dwarf planet would contract inward, causing the surface to crumple and compress. Instead, the faults on Pluto show a crust that is expanding outward. Because standard ice expands when it freezes, this specific geologic scarring indicates that the freezing process is incomplete. A liquid ocean still survives, likely insulated from the vacuum of space by a thick blanket of nitrogen and methane ice. These vast tectonic canyons function as thermodynamic receipts. They provide a structural record proving that liquid water remains trapped in the depths below. The outer solar system exists as a vast archipelago of dynamic, hidden oceans. Finding so much liquid water far beyond the reach of the sun's warmth changes the calculations for where life might be able to survive. The newly launched Europa Clipper represents the next evolutionary step, testing whether these oceans hold the specific chemical ingredients to sustain life. Mastering the invisible physics of these worlds proves that liquid water is a cosmic norm, persisting deep beneath the ice of our neighbors.